Okay, looking at problem number 5, we say generation Y has been defined as those individuals who were born between 1981 and 1991. In a 2010 survey, found that 53% of young adults pay their monthly bills on time. Suppose we take a random sample of 190 people from Generation Y, complete the parts A through E below. So to calculate the standard error of the proportion, first of all, we know that P equals 0.53, and we know that N equals 190. So to calculate the standard error for the proportion, we would do the square root of 0.53 times 0.47 divided by 190. So if you calculate that, you will get 0.0362. So we know the standard error of the proportion is 0.0362. So we will put that in our information up here to calculate each of the following. For B, what is the probability that 120 or fewer? So we need to do 120 divided by 190. So if you do 120 divided by 190, you will get 0.632. So our probability to calculate our Z would be 0.632 minus our proportion of 0.53 divided by the standard error, which is 0.0362. So if you calculate that, you will get 2.82 for Z. So you will look that up in your table. And when you look that up in your table, you will see that the probability is 0.9976. So that is the answer to B. Now for C, what is the probability that 95 or fewer will pay their bills on time? So this number will change here. The other two numbers stay the same. The only thing that's changing is that first proportion. Our proportion there is 95 divided by 190, which is half, or 0.5. So we put 0.50 right here, minus 0.53 divided by 0.0362, and you will get negative 0.83. And if you look that up in your table, you will get 0.2033. So that is the answer for C. For D, what is the probability that 106 or more will pay their bills on time? Well, first we have to find the probability of 106 or less, and then once we find that, we can subtract that from 1 to get the greater than side. So first of all, we have to come up with a proportion to put right here. So 106 out of 190, if you do 106 out of 190 divided by 190, you get 0.558 minus 0.53 divided by 0.0362. So if you do that, put that in your calculator, you will get 0.77, and if you look that up in your table, the probability is going to be 0.7794, and that probability is to the left, the less than side. So if we want to know the probability of finding greater than 106, we would do 1 minus 0.7794, and that would be 0.2206. Okay, and then what is the probability that between 97 and 110 of them will pay their bill on time? Well, what we have to do is we have to do one calculation for 97 and one calculation for 110. So I'm going to make more room here to do that. So 97 out of 190 and 110 out of 190. So 97 out of 190 and then 110 out of 190. When you do 97 out of 190, you get 0.511. So to find the z-score, 0.511 minus 0.53 divided by your standard error, which is 0.0362. For this z-score, 110 out of 190 is 0.58, so we're going to do 0.58 minus 0.53 divided by 0.0362. So if you do those z-scores, you will get negative 0.52 and 1.38. So you have to look those up in your table, and like I said, if you want to print your table out, that might make it a little bit easier. But when you do that, I believe you get 0.9167 over here, or 9162. And then over here you get 0.3015. So we have to take these two. This is area to the complete left. We want to subtract the 0.3015 out, and we get 0.6147. We have to subtract out the area that we do not want in there. The area under 97 we don't want that to be included. This is the area under 97, so we have to subtract that out. So you get 0.6147. Now I'm going to scroll up here. 0.6147. So that is the end of that question. So moving on to question 6, problem 6. This is, you're going to find the standard error again of the proportion, and you're basically going to work at the same, this is the same type of problem here. Here I just rounded wrong, so that's why I have red there. But this is worked the same way, so I'm going to skip that one. Question number 7, you're going to calculate the standard was the probability that less than 79%, between 70 and 80%. And then let's look at D. What impact would change the sample size to 200 teams? So if we change the sample size from 150 to 200, well, that would mean that the standard error would be reduced, because when you increase the sample size, it's going to be closer to the population. It's going to be more representative of the population. So anytime you increase your sample size, you are decreasing the standard error. Question number 8. Let's see here. Standard error of proportion, same calculations. But down here, if 86 parents responded they are friends with their children on online network site, does this result support the findings of the social media? Well, what you can do there on 7.5, problem 8, let me look at my calculations. You can actually work this one out and see if it makes sense. I'm trying to see if I did work this one out. I don't believe I did on C. But I know I do later on. But you can actually work this out and see if the probability is less than 0.05. Let's see if I can find one where I did that. These are all self-explanatory, same types of problems. Question 10. The standard error would be reduced. That's still the same type of question. Question number 11 is the one, okay, here I accidentally marked the wrong one, but if you do 51 members, if 51 members use a course at least once a week, you would do 51 out of the 100 sample, and that would be 0.51. You would use 0.51 minus 0.39 divided by the standard error, which is, you will calculate right here. And when you do all that and you actually get your Z-score is 7.5. Let me look and see if I can find it. 7.5 D. I believe your Z-score is, we want to know 51 or more members. So we have to say 1 minus 0.9979, which is the probability you will get. So the likelihood of that happening is 0.0021. So what that means is, does this support the historical records of course usage? Well, the historical records show that 39%, but what we see is, since the probability of attaining a result this large is small, then it does not support what we found. Okay? If 51 members use the course at least once a week, does this support the records of court usage? No, it does not, because the probability of attaining a result this large is very small. And then problem 12, basically, same thing here. Without the finite correction factor, if you don't have that, then your standard error is going to be overestimated. So when you use the finite correction factor, that helps keep your standard error from being overestimated. And you can read about that in the example. It may help you to understand that correction factor a little bit better. And then on question number 13, managers at a retail have a goal that 75% of the customers will have to wait less than 5 minutes. Okay, and we can look at a sample here. So what I had to do is I had to figure out what proportion of the customers count how many was less than 5 minutes. Okay, I had to count the number of times where it was less than 5 minutes. And I believe when I counted that, let me see if I can find it. 7.5, problem 13. I got all my pages mixed up here. Okay, 7.5, problem 13. When I counted them, there was 17 of them. That was 17 out of 25 that were less than 5 minutes. So what I can do is I can calculate my standard error, which would be 0.75 times 0.25 divided by 25, and take the square root, and I got I believe 0.0866. So then what I have to do is calculate my Z-score. Well, 17 out of 25 is 0.68. So 0.68 minus 0.75 divided by 0.0866. Once you do that, you get negative 0.81. So if you look that up in your probability in your table, you get 0.2090. So what does that mean? Does this sample provide evidence that management's goal is being achieved? Well, yes, because the probability of observing a sample proportion as low as this one in the sample, given a population proportion of 0.79, is 0.209, which is more than 0.05. So this supports the evidence that the goal is being achieved because of this number right here. If this number had been less than 0.05, then no, it wouldn't support this. Okay, it would not support the 75%. But since this number is greater than 0.05, then it does support the management's goal of 75%.